This is 4-3, angle relationships in triangles. Pause the video to reveal the answers to the warm-up when you are ready. So number 1's 150 degrees because these two angles are linear pairs. They're supplementary, they add up to 180 degrees. Number 2, the complement would be 73 because complement is 90 minus the angle measure provided, so 90 minus 17, 73 degrees. And number 3, how many lines can be drawn through N parallel to line segment MP? I drew my one line that's possible there for you guys, and it's because of the parallel postulate. We talked about this in the last section even prior to having a theorem about it. It's the triangle sum theorem, and it just says that all the angles of a triangle add up to 180 degrees. Okay, here it says the map of France, commonly used in the 1600s, was significantly revised as a result of triangulation land survey. The diagram shows part of the survey map. Use the diagram to find the indicated angle measures. So measure of angle NKM. NKM. Okay, so we've used 88 and 48 of 180 degrees. We add those first. We get 136 degrees. We're going to subtract that from 180. And we get 44 degrees. So the measure of angle NKM is equal to 44 degrees. How about the measure of angle JKL? Now let's change my color. So JKL. Okay, I'm placing in my 44 degrees. So these three are a semicircle. They add up to 180 degrees, those three angles. So therefore we would do 104 plus the 44, which gets us 148. And we're going to subtract 180 minus 148 to get the measure of angle JKL, which is about 32, which is exactly 32 degrees. Alright, I want you guys to try the now you try area. Pause the video while you do that and then hit play when you're ready to see how to do this work. Okay, in order to find the measure of angle XYZ, we have to add what we have so far in that triangle, which is 62 and 40, and that gets us 102. And then we would subtract that from 180 to get the missing angle measure, and that's going to be 78 degrees. Measure of angle YWZ. Measure angle YWZ. Well, we know that that's 78, and 78 plus 12 is 90 degrees. So this is a right triangle, 90 degrees. And now we're trying to find YWZ, which is right here. Remember our middle number is the angle, our middle letter is the angle that we're looking for. So we're looking at angle W here. And so we've used 90 and 40 so far. 90 and 40 add up to 130 degrees. We're now going to subtract that from 180. And we should get 50 degrees for measure of angle YWZ, or measure of angle W. There are two corollaries. A corollary is a theorem whose proof follows directly from another theorem. So knowing that our triangle sum theorem, knowing that the triangle adds up to 180 degrees is where these corollaries are kind of coming from here. So it says the acute angles of a right triangle are complementary. So if we have a right triangle, we've used up 90 already, and what we're saying is that the leftover two angles would add up to 90 degrees. So if angle D is 30, I already know angle E is 60, or if angle D is 40, I already know angle E is 50. Okay, the measure of each angle of an equiangular triangle is 60 degrees. So if it's equiangular, if all three angles are congruent, then each of them has to be 60 degrees. So again, they're corollaries. It's a theorem whose proof follows directly from another theorem. Because we know the angles add up to 180, the rest of these corollaries make sense. Okay, now it says one of the acute angles in a right triangle measures 22.9. So I've got my right triangle. One of these is 22.9. What's the measure of the other? Well, I don't have to add 90 plus 22.9 in this case because I already know that it's going to just be subtracted from 90. So the measure of the other acute angle would be 67.1 degrees. And if we check, we add them all up, that would add up to 180 degrees. The corollary says that these two angles, the non-right angles, are going to add up to 90 degrees. Okay, one of the acute angles in a right triangle measures 2x. Well, to find the other one, we would subtract from 90. So I'm just doing 90 minus 2x. It says, hint, your answer will be an algebraic expression because I cannot subtract 2x from 90 since they're not like terms. So that's my final answer. Okay, we have interior angles of a triangle, and we have an exterior angle that can be formed if we continue one of these lines. We've got this exterior angle, angle 4, that can be formed. So interior, the angle's inside, exterior is the angle outside. Okay, we also have remote interior angles. Remote interior angles are not adjacent to the exterior angle. So in this case, angles 1 and 2 are my remote interior angles because they're not adjacent to my exterior angle, which is angle 4. Okay, exterior angle theorem. This seems to be one of those theorems that everyone tends to forget, and there are other ways to do it, but what you need to know is that this outside angle, measure of angle 4, is equal to the measure of angle 1 plus the measure of angle 2. Okay, so I see my exterior angle is 126, and that is equal to the sum of the remote interior angles. My remote interior angles are the ones that are not touching the 126 degrees. So therefore, 6x minus 1 plus 5x plus 17 is equal to 126 degrees. Combine like terms, I get 11x plus 16 equals 126. Subtract 16 from both sides. 11x equals 110. And divide both sides by 11. We get x equals 10. Okay, in this example, my angle 15 and degrees and the 2x plus 3 degrees are my remote interior angles. My exterior angle is 5x minus 60. Therefore, I have 15. So I'm adding my remote interior angles, setting them equal to the exterior angle, 5x minus 60 degrees. So I can combine like terms. 15 and 3 becomes 18 plus 2x is equal to 5x minus 60. I could subtract 2x from both sides, and I can add 60 to both sides. And we end up with 98 equals 3x. Okay, third angle theorem says if two angles of one triangle are congruent to two angles of another, then the third angles must also be congruent. And let's make it make sense. I'm just going to make up random numbers. So say this one's 30 and this one is 70. So we've used 100 for each of these, and we can go up to 180. That means that this one must be 80 degrees, and same with that. So that's why it always works out that if you have two of the angles congruent, then the third angle is already congruent. Okay, so for example 4, find the measure of angle K and the measure of angle J. K and J. So since we know that we've got these angles congruent, and these two angles congruent, then these ones must be congruent to each other. So I can set them equal to each other. 6y squared minus 40 equals 4y squared. I can subtract 4y squared from both sides. That leaves me with 2y squared minus 40 equals 0. I can add 40 to both sides. And I get 2y squared equals 40. Divide by 2, divide by 2, I get y squared equals 20. Get rid of the squared, I can square root each side, and y equals the square root of 20, which can be simplified. We start with a factor tree, 4 and 5, and 2 and 2, and we could take out the pairs, because the square root of 4 comes out as a 2. So y equals 2 radical 5. So the non-simplified version is a little bit easier to work with as we plug it in. So 4y squared, 4 times radical 20 squared. Notice I put that in parentheses, so 4 times, do my exponents first, radical 20 times radical 20. Well, a radical times itself becomes the whole number that's inside, so 4 times 20, which is 80 degrees for each of these. Okay, find the measure of angle C and the measure of angle F. Well, since we know that they are going to be equal to each other because of the third angle's theorem, we can set them equal to each other. So y squared equals 3y squared minus 72. Subtract 3y squared from both sides. Get negative 2y squared is equal to negative 72. Divide both sides by negative 2. Get y squared equals 36 and square root each side, and y equals plus or minus 6.